Hey guys, how are you doing? Are you feeling good? I hope so. We're gonna talk today about similarity. But when we talk about similarity, we have to remember congruency. For example, look at this question or look at these pictures. You're gonna find here two dancer monkeys, and you're gonna find an important relation between these, that you have the same shape exactly in the same position and the same size too. Every single thing is same. So in this case we're gonna say what? Congruency. Why? Because we have same shape and same size. Okay? But in this picture you're gonna find what? You're gonna find the same position exactly, the same shape of these dancer monkeys. But we're gonna find that the size is different. So we're gonna say here similar shapes. Similar. And we're gonna say what? So we have similarity between these two dancer monkeys. So we have same shape, but we have here different size. That's it. So we're gonna talk today about similarity, only similarity. Okay, let's get started. This question is saying triangle ABC is similar to triangle DEF. So ABC is similar to DEF. Okay, why he didn't say congruent? Excellent, because we have different sizes, like this one exactly. Don't forget, different sizes. So you're gonna talk about similarity. So these two triangles are similar. Okay, so can you calculate the value of x, this letter A, the first point? Can you find x, which is here? How can you get it? Firstly, you have to look at the numbers which you have. You have your 8, you have your 10, and you have your y. This is unknown. Okay, here you have 6, here you have 9, and this is unknown. What are you going to do in this case? Firstly, compare between the corresponding sides. And what is the meaning of corresponding sides? Corresponding sides means the side, for example, this side the blue one is corresponding to which side here? Great, AD. Excellent. So this side like this side exactly. And we have another corresponding sides, of course, like what? AC is corresponding to well done, DF. And BC so I'm putting different colors to notice the corresponding sides. It's congruent, it's corresponding to what? EF. Great. So we have three sides, and we have same shapes. Because of that we have corresponding sides. Great. So now you're gonna notice something that you have for these corresponding sides here. You have here a number, okay, and you have here a number. I'm talking about numbers. Here we have what? Look, 10, and here unknown. So there's a problem. Look, 10 is corresponding to x, and x is what? Is unknown. And you have here y is corresponding to 9. So we're gonna take only the golden numbers. Golden numbers mean the numbers which have the same position. Look, this is corresponding to this. So this is gonna be the scale factor. Scale factor. The scale factor is going to be what? Great, it's going to be 8 over 6. So if we consider that we're going to move from this to this, if you want to move from the small to the big, you're going to write another scale factor. So the scale factor in this case is going to be what? 6 over 8. Great. This is the first point. You have to keep it here, and you're gonna solve this question now. What do you need? You find x. So x, where is it? Here. In the small triangle or the big? So this is the big one, and this is the small one. So you need to find x, and x is related to what? To the small one. So which scale factor are you going to use? If you want to find a small side or a side in a small triangle, the small shape, what are you going to do? Yes, you're going to use what? Great, you're going to use this one. If you want to find a small thing, you're going to use the small scale factor. So you're going to write x equals 6/8 times what? Times a number here corresponding to x. X is here and corresponding to 10. So I'm going to write here 10. Now you're going to get the answer. What's going to be? Think. Excellent. It's going to be 7.5. Great. 7.5. And write the same unit, which is centimeter. Again, if you want to find x, ask yourself, x is in the small shape or the big shape? Yes, great, small shape. So you're gonna write x equals and write the small scale factor, which is 6/8. Why? Because you need to find a small thing here. So you're gonna use the small thing and write times what? The corresponding number to x, which is 10, to get the answer directly. Let's solve another question. Again, we have corresponding sides here, and we get it already. We said this is corresponding to this, and these are the golden numbers. Why? We're going to use these numbers to help us to find any messing. For example, the scale factor in this case equals 8/6, or scale factor equals 6/8. Sorry, 6/8. What are you going to find? Of course, this is the big one, and this is the small one. We get this already. He's asking to find y. Ask yourself, why? In the big one or small? Big. So you're going to use the big scale factor. So y equals, excellent. I'm going to write here 8/6 times, y is corresponding to what? Y is corresponding to 9. So times 9 equals, excellent, 12 centimeter. So we got this question. Now another one. Okay, here he's saying triangle ABC is similar to triangle PQR. These two triangles, of course, I'm going to write here big, small, and small here. And we have here, this is corresponding to this, and this one is corresponding to this one. Means the same places. Okay, and this one is corresponding to this one. Okay, he's asking only to find PQ, which is here. So I need to find this one. So I'm going to write the scale factor equals 12.4 over 21.7. So, or 21.7 over 12.4. Now we're going to find PQ. Ask yourself, PQ is what, big or small? Where is it? Here. Yeah, of course, big. So I'm going to write big. Of course, I'm going to use this formula. So 21.7 over 12.4 times what? Yeah, it's corresponding to what? This PQ. Excellent. 5.2 equals, what's going to be the answer? Great, it's going to be 9.1 centimeter. Great. The next one. We have a problem in this question, that we have the two triangles overlapped, which is CBA, the big one, and the small one, which is CED. So you have two triangles but overlapped. What we're going to do, we're going to separate them. Like, I'm going to draw here the first one, which is here, C, E, D. And draw the big one. Don't draw only this part. It's not a triangle. This is a trapezium. So you're going to draw all of it, the big one, but without drawing the line between them, of course. Okay, this is the big one, which is C, B, A, or A, B, C. So this is the small one, which is here, and the big one, which is C, B, A. Okay, let me draw it here in different color, the same color of the big one. Yes, and it's better to write the numbers on both of them. Okay, here we have 6 centimeter. Here we don't have it. This K centimeter means it's unknown. Here we have CB equals what? From C to B is going to be what? X is going to be 10.8 centimeter, and this is 9 centimeter. Now what we're going to do, the corresponding sides, or the sides in the same places. So 9 like K here, 9 like K. So these are not the golden numbers. So we have another 2 numbers here, this one and this one. Of course, I'm going to form the scale factor using these 2 numbers. So the scale factor equals 10.8 over 6, or 6 over 10.8. Now we're gonna find the answer. He's saying here what? Find K. So if you want to find K, ask yourself, K is big or small? We have here the small, and we have here the big one, and K is what? K is related to the small one. So small, I'm gonna use, of course, this one. So 6 over 10.8 times K is corresponding to what? Yes, great. The orange, like the orange, times 9 equals, great, it's going to be 5 centimeter. Okay, some students are writing the scale factor in simplest form. If you're going to write 10.8 or over 6 on the calculator, it's going to be whole numbers up and down. No problem to use this one or the answer, which is going to be simplified on the calculator. Okay, but finally the answer is going to be what? 5.